Hi everyone, welcome to Chemistry, Chapter 6, Planet Earth, Part 1, the Atmosphere. What is atmosphere? It is a layer of gases surrounding the Earth. It contains different gases. In Form 2IS, you have learned the components of the air. So now please complete the table below. I think that most of you is able to tell me that the major component of the air is the nitrogen. How about the second one, which is very important to our body cells? Yes, oxygen. The third one, noble gases, for example, argon or neon. Then the fourth one, carbon dioxide. And then the last one, water vapor. It is because the component in the air have many different uses, so the chemists would like to separate them out. The uses are listed below. Oxygen gas, pure oxygen gas would be supplied to the patient who has difficulty in breathing. Then the liquid nitrogen, it would keep the things frozen. And then argon will protect the filament in the light bulb from being burnt. Then this picture I post here, it is a setup of fractional distillations in the real situation in the industry. So it looked complicated. So at this moment, as a real work, I do not go to further details. In the contrast, I now would tell you about the basic working principle of the fractional distillations. The first thing that you have to know, which is very important, is the boiling points of each gas I list below. Nitrogen, it would boil. It means that it would change from liquid state to gas state at negative 196 degrees Celsius. And then argon, it would change from liquid to gas at negative 186 degrees Celsius. And then oxygen, it would change from liquid to gas at negative 183 degrees Celsius. Then now I would show you an animation which helped me to elaborate the concept. Now, it is an animation. Now in the container, in the closed system, there are argon particle. Then the temperature is negative 187. Argon would boil. It means that to become gas at negative 186. So I would now heat it up. Now it vibrates, and then I would heat it up to around negative 170 degrees Celsius. Then you will see that they will separate, they will move freely. They would and then you can imagine if the container now is not in a closed system, it is open. So what would happen to them? Yes, they would escape. They would move out. It is a very important concept here. So the working principle about fractional distillation is that they boil and then they would escape. Then I have a diagram below to help you to consolidate the concept about fractional distillation. Then if now the temperature if now I have a liquid air in a beaker which is open to the surrounding, then you will see I have different particles inside. The red one would be nitrogen, the blue one would represent argon, and then the green one represent oxygen. Then if I heat it up slowly, the first temperature I use is negative 196 degrees Celsius. I may provide you the boiling point. The boiling point of nitrogen is negative 196. Argon is negative 186 degrees Celsius. and the oxygen is negative 183 degrees Celsius. Then if now I heat the container at negative 196, then what would happen? Oh, some of you would be able to think about that the nitrogen particles will become gases and escape. So the red one would come out, right? And then this one, oh sorry, come out, the red one, and then this one. So most of the nitrogen particles will come out, they escape from the container. Then the second temperature that I would use would be negative 186 degrees Celsius. Then think about what would come out. Yes, the argon particle, the blue one come out. Okay, and then I try to separate them. Yes. Oh, sorry. Yes. Okay, and then the last temperature I would use will be negative 183 degrees Celsius. So I'm pretty sure that you know that now will be the oxygen particles would come out. Oh, sorry. So we are able to separate them one by one. They're in pure form. So I hope you get the basic working principle of fractional distillations, and then please complete the exercise and test it. And then the next video, it would be about the details of fractional distillations of liquid air. So see you.